So we're going to be solving practice problem 3.3 in this video from the book of Fundamentals of Electric Circuit by Charles Alexander. So in practice problem 3.3 we have this question of nodal analysis and we have a case of supernode. So we have been asked to find out the voltage V and the current I, which have been denoted by the symbols V and I in the circuit shown. Okay, so the very first step that we are going to do is to identify the direction of current flowing in the circuit. Okay, so we can name this node V1, this would be node V2, and the current is flowing here, the current is flowing here, the current comes from the source, from the battery, goes into the 4 ohm resistor, and it goes here. Alright, so as we can see that we have a case of supernode in this practice problem 3.3. So the very first step that we are going to do is write down the equation of supernode. Step number 1. And write equation of supernode. And then step number 2 would be to write down the merge equation of current entering and current leaving both the junctions V1 and V2 using KCL. So we can write merge equation of sum of currents in is equals to sum of currents out for both nodes V1 and V2 using KCL, or which is also known as nodal analysis. Alright, so the equation for supernode would be V2 minus V1 is equals to 6 volts, because the positive polarity is facing the V2 node and while the negative polarity is facing V1 node. Alright, so as we can see that the voltage V that we have been asked to find out right here, we have this same voltage would be applied on this node that I have named V1. So I'm going to be finding out the node voltage V1, which would also be the answer for the voltage V, which we have been asked in the question. Okay, let us write down the merge equation. So the current entering is 14 minus V1 divided by 4, and the current leaving is V1 by 3 plus V2 by 2 plus V2 by 6. Alright, so we can now simplify these. It's going to become 14 divided by 4 is 3.5 minus 1 over 4 V1 minus 1 over 3 V1 minus half V2 minus 1 by 6 V2. Alright, so minus 1 by 4 minus 1 by 3 is minus 7 by 12 V1 minus half, and minus 1 by 6 is minus 2 by 3 V2 is equals to minus 3.5. So taking negative sign common, we have 7 over 2 V1 plus 2 over 3 V2 is equals to 3.5. Okay, this is equation number 1, and this right here is equation number 2 of the supernode. Now we can simultaneously solve these equations in order to get the correct answers. Okay, I'm going to be using the calculator to plug in these equations. Minus 1, 1 and 6. 7 divided by 12, 2 divided by 3, and 3.5. So here we have the answers for V1 and V2. V1 is minus 0.4, while V2 is 5.6 volts. All right. So now we know that the voltage required in the question is V, and we have the same voltage at the node V1. So V1 is equals to V. Therefore, V1 is equals to V. Therefore, V is equals to minus 400 millivolts. Right? Okay, now we have been asked to find out the current I as well. Current I, according to Ohm's law, says I is equals to V upon R, and I is equals to, we know the voltage that we just found for V2, which is 5.6. 5.6 divided by, what is the resistance? The resistance is 2. 5.6 divided by 2 gives us 2.8 amperes. I hope this question was clear to you guys, and I will meet you guys in the next video.